Once you've donned your harness and your lanyard, you'll need to make sure you tie off to an anchor that will keep you from hitting a lower level or object as you fall. You'll also need to make sure your setup will keep you from experiencing fall arrest forces that are unsafe as your fall is stopped. First, let's figure out how you can make certain you have enough clearance. Our assistant, Abel Wiseman, has reluctantly volunteered to help us demonstrate how to calculate it. He's wearing a typical fall arrest system made up of a full-body harness and a lanyard that has a built-in energy absorber. He is using the I-beam as his anchorage and has secured a cable wrap around it to act as his anchor. His lanyard is connected to the cable wrap at one end, with the other end connected to his harness at the dorsal D-ring, or in other words, the D-ring on his back. Abel, please step off the platform for us. Abel, you're a cartoon. You'll be okay. Abel, are you okay? Now let's take a close look at the fall arrest system working in slow motion as Abel fell. The first action was the lanyard pulling tight or becoming taut. Until the lanyard is taut, Abel is in free fall. Knowing your free fall distance is a critical step in setting up your fall arrest system, and we'll discuss this in great detail a little later. Abel's free fall in this example was 3 feet, but his fall hasn't stopped yet. Immediately after free fall, when the equipment is under strain and begins to pull tight, the D-ring will slide up the back harness straps to rest level with the top of Abel's head. During this sliding of the D-ring, Abel drops about another foot. The third and final action of the fall arrest system is the deployment or stretching out of the energy absorber. Energy absorbers reduce the amount of force on your body as you fall. Written on each one is its maximum elongation. This distance is the additional length that it will extend as it deploys and absorbs some of the fall's arrest forces. When calculating your clearance, you must always include this fully deployed length. It may vary depending on the type and manufacturer, so you must check it each time. Abel's energy absorber indicates that its maximum elongation is 3.5 feet. Once it stops stretching, Abel's fall is finally stopped. Now we can put our numbers together and calculate how much clearance Abel needed from his anchorage. Let's start right up at the I-beam. His cable wrap is hanging approximately 2 feet below the I-beam. His lanyard was 6 feet long and his energy absorber has deployed an additional 3.5 feet. Because his D-ring is now at the top of his head, we need only put in his height, which is 6 inches. Pardon me, I mean 6 feet. No offense, Abel. Now you will notice Abel's feet are about 2.5 feet above the ground. He has at least an extra 2 feet of clearance. Some jurisdictions require a minimum of 2 feet, while others require at least 3 feet. Either way, these extra 2 to 3 feet must be there. It's to account for extra stretch in the fall arrest system or extra D-ring slippage. So what it comes down to is that in order to calculate how much clearance you need, you must add up all the lengths of your fall arrest equipment, including the fully deployed energy absorber, then add it to your height, and finally put in a couple of feet for safety. Here, Abel needed 19.5 feet of clearance from the I-beam, or 17.5 feet from the anchorage connector, or cable wrap.